Good evening and welcome to UW Space Place. Tonight is the second Tuesday of the month, so we have a special presentation tonight. And because of the day on which the presentation falls, we're devoting it to the New Horizons spacecraft, which is flying by, actually has, by the time I'm giving this talk now, it's already flown by the planet Pluto. This is a really interesting interplanetary mission for a lot of reasons, including that it's filling in the exploration of the solar system, but it's also the first one in many years that we've had a spacecraft now arrive at a new planet. So we're going to talk about New Horizons and the exploration of Pluto. So Pluto was the last, or maybe I should say the most recent, in a long line of planet discoveries. There's a lot of things out there orbiting the sun, and we only count some of them as planets. This is actually an issue that's come up quite a lot in history. What do we call a planet? We all know that there's always a lot of discussion since 2006 about whether Pluto is a planet or not, which is really kind of a side issue. But how they got discovered is really pretty interesting. Most of the planets, the ones that you see in the sky, like Venus and Jupiter, which we can see in the evening skies these days, or Saturn, and then also Mars and Mercury. Those 5 planets have been known since antiquity. We don't know who discovered them, if anybody. They've been known to be different from the stars as long as we have any historical records. And so when in 1781, an astronomer named William Herschel saw a thing through his telescope that he decided was not a star, the first thing to come to his mind was not that this might be a planet, because nobody had ever discovered a planet. All the planets were known to the ancient Greeks, and probably long before that. Herschel, however, decided eventually that it had to be one. At first he thought it was a comet, but it actually turned out to be a planet. It turned out this thing was in a circular orbit around the sun, and that was the planet Uranus. That was a pretty significant event. You talk about broadening people's horizons. It made people realize that maybe there was stuff out there that astronomers didn't know about. So that was a big step, the first discovery of a planet, 1781. The next planet to be discovered was Ceres. How many people have heard of Ceres? A few, good. So these days we usually classify Ceres as an asteroid or a dwarf planet, but it was actually considered a planet when first discovered in 1801. By an Italian astronomer, Giuseppe Piazzi, who, like Herschel, looked in his telescope and saw something that wasn't on the star charts and wasn't a planet that he already knew about. He saw this thing moving through the sky. You don't see it all at once, but night after night, you see it moving against the stars. He discovered that it was orbiting around the sun, and this was declared to be a new planet. In the case of Ceres, after a few years, another object was found in about the same orbit. And then another object was found in about the same orbit. And every one of those was being declared a planet. And then another one was discovered in the same orbit, and then another one. And if you look in some early 19th century textbooks, you can find lists of planets where there's 15 or 16 planets. And most of them are the ones you would recognize, and all the rest are what we now call asteroids. And astronomers became, in the 1840s, became a little uncomfortable with the idea that suddenly there were going to be too many planets. And so they demoted all those planets to asteroids. They basically made up the term asteroid and categorized all of those things that are about that same place as asteroids, not planets. So it was a planet discovery when it was discovered, but then demoted. But then in 1846, something we recognize as a planet was discovered. The planet Neptune was discovered because astronomers had been watching Uranus long enough to notice that its orbit wasn't successfully predicted by Newton's laws. It ought to. Gravity ought to be what's operating out there, but Newton wasn't, not Newton. Newton was doing exactly what he should have. Uranus was not quite doing what it should do. And so a couple of bright astronomers said, well, maybe there's another planet out there disturbing it. So they sort of hypothesized a model where there's another planet out there. And if that planet were in a certain place and it had a certain mass, then it would produce the disturbances they were observing in Uranus. So they go take a look. Actually, it wasn't them. Some other astronomers, based on their advice, took a look, and guess what? They discover a planet pretty much where these guys had suggested that they should look. That was the planet Neptune. So that was a big deal. That was the first planet to be discovered, so to speak, theoretically. Its existence was inferred before anybody had ever seen it. Then in the 1870s, another planet was discovered. This planet is called Vulcan, and I've got it in parentheses because, of course, it doesn't actually exist. This is not the one from Star Trek. In those days, astronomers were looking at Mercury, and there was a similar problem to the problem with Uranus. Its orbit wasn't quite right. And so they thought, well, it might be not quite right because there's a planet disturbing its motion. And the whole thing with Neptune had been very successful. So they started looking for a planet closer to the sun than Mercury, an intra-Mercurian planet, to explain the disturbances in Mercury's orbit. A few astronomers, including a local one, thought that they had discovered Vulcan and actually announced to the world that they had discovered Vulcan. The problem is that it's very hard to see things close to the sun. What they did was wait for a solar eclipse, a total solar eclipse, to cover up the sun, and then you've got maybe 2, 3, 4 minutes to search the sky for this planet. And that's apparently when probably somebody miscounted a star or maybe an asteroid or something and thought they had a planet. So that turned out not to be a planet, but it was announced as a planet discovery. So there had been, the point is, there's a long line of planet discoveries before we ever get to Pluto. By the time we get to Pluto, astronomers are used to discovering planets. And Pluto came along in 1930. The way Pluto was found is interesting. It was not a theoretical sort of thing. It was a result of a deliberate search, sort of like Neptune was the result of a deliberate search. And it was for a similar reason, because astronomers had been looking at Neptune long enough to think that maybe its orbit wasn't quite doing what it should do. And so the obvious thing is to think about another planet that might be disturbing Neptune's motion. So a number of astronomers came to this conclusion and thought about devoting a search for the purposes of finding this planet beyond Neptune. One of them was Percival Lowell, who is probably most famous for some other things involving canals on Mars. But Percival Lowell, who had established the Lowell Observatory, which still operates in Flagstaff, Arizona. Lowell was wealthy enough to fund his own astronomical projects and build his own observatories when he saw fit. And Lowell decided to start a search for this planet which might be disturbing Neptune's orbit. However, it was actually long delayed. You note that it says there that the search begins in 1929. Lowell actually died shortly after putting this plan together. And then there was a long lawsuit from his family about whether this crazy plan to fund astronomy really ought to be allowed. And it went on for quite a few years. The search then didn't start until 1929, when all that litigation was finished, and the courts decided that Percival Lowell's will should be observed, and his money should fund astronomy, which is what he wanted it to do. And then it produced fruit rather rapidly. So the Lowell Observatory began the search for Pluto. They hired an assistant, an observing assistant named Clyde Tombaugh, who had very little, in fact, really no professional astronomical training. He was sort of a self-taught astronomer at that time, and wrote a letter to the observatory saying, I want to be an astronomer, and I've built my own telescope, and I'm willing to work long hours. And they hired him to be the observing assistant, and they gave him, okay, here's this project. Here's what you do. You go out to the telescope we're using to search. It's a photographic telescope. You photograph a part of the sky, and then a week later, you do the same thing to the same part of the sky. Meanwhile, you spend the rest of the night taking pictures of other places in the sky, which a week later you're going to come back and compare. And then you're going to compare those two photographs and see whether anything moved. If we didn't have the arrows on here, I'm willing to bet that you couldn't find the planet in this picture. So Clyde Tombaugh started searching pairs of plates. He had a special sort of microscope called a blink comparator that would allow him to look at first one and then the other, and he could flip the view back and forth with a mirror. And if you get them registered just right, then nothing, if the stars haven't changed their patterns, then nothing changes. So you can check that plate, and then you can do another pair and another pair. And he searched those until February of 1930, which is remarkably fast since they only started sometime in 1929. And on this plate, he found a little dot that moved from there to there. So that was the discovery of Pluto. This was big news, as planet discoveries always are, in 1930. But this one was something that, unlike Vulcan, that other astronomers were able to confirm. Other astronomers were able to look at that same place in the sky, find that same dot moving, and it was almost immediately agreed that a new planet had been added to the solar system. The problem is it's so dim. It must be really, really far away. And it was hard to learn anything significant about it because of how tiny it is. And it moves so slowly, so they knew it was very far away. It must take a long time to go around the sun, given how far you can see it move in a given pair of frames or after some amount of study. In fact, it turns out to be about 248 years it takes to go around the sun one time. So the discovery of Pluto here was immediately acclaimed, and it was declared right away to be a planet. It was assumed, the orbit for the planet was understood fairly quickly, and right away it became apparent that there was something a little bit odd about it. It's very far out, as it says here, 248 years is how long it takes to go around the sun, so longer by a lot than any other planet. But oddly, and unlike the other planets, its orbit is very elliptical. That is, it comes in relatively close to the sun and goes relatively far away. Most of the planetary orbits, while not perfectly circular, they're close to circles. If you drew them to scale on a piece of paper, they look like circles, but not Pluto's orbit. Pluto comes nearly as close to the sun. In fact, it comes actually a little bit closer to the sun than Neptune ever gets. And then it goes way far out. About 10 astronomical units further out, about 10 times the distance of the Earth, farther out when at its extreme. So that's very elliptical for a planet. It's not at all elliptical for a comet. Comets do this kind of thing, and there are plenty of asteroids that are in pretty elliptical orbits. For a planet, that's kind of unusual. So right at the beginning, Pluto was beginning to look a little bit suspicious. For a little while, because its orbit comes into, at its closest point to the sun, it comes into the same distance as Neptune, although the two orbits don't actually intersect. So it's out there in space. It looks like whenever you draw it, it looks like they intersect. They actually don't. So they won't collide with each other. In fact, they turn out to be in what astronomers call a resonance with each other, so that they actually have kind of an arrangement where they don't collide. But because they come so close together, there was a theory right away that maybe it was an escaped moon of Neptune. So already its planetary status is suspicious. If a moon escapes from a planet and goes into orbit around the sun, is that a planet? Well, I don't know. But at any rate, the theory was that it was an escaped moon of Neptune, although, as I read now, they don't think that that's got anything, that's a reasonable explanation of where Pluto came from. But that was something that was kicked around right away. And again, casting a little shadow over its planetary nature. Originally, it was estimated to be about the same mass as the Earth, actually for no particularly good reason, except that it wasn't huge like Jupiter or something along that line. So it just kind of estimated to be the mass of the Earth. And the first good data for that didn't come along until 1976. So it was discovered in 1930. So nearly 50 years later, astronomers discovered that actually the color of it looked like what you would get if it was coated with methane, if it had methane ice on its surface. And if it has methane ice, then you know about how bright that should be. And if you know about how bright it looks, they call this the albedo. If you know about how bright it looks, and you know how bright you see it out there in the sky, then you know about how much light it's reflecting from the sun, and you can make an estimate of its size. How big does it have to be to reflect that much light? Well, if it's icy, then it can be a lot smaller and reflect the same amount of light. And so in 1976, after that measurement of the albedo came about, astronomers realized that it must be a lot smaller than the Earth. And the estimate was then about 1% of the Earth's mass, so a dramatic reduction, a factor of 100. In 1978, its moon, what we now call its moon, although I'm going to change what I call it in a minute, it discovered that there were actually two objects out there. One of them, the moon, is now called Charon. Charon and Pluto orbit around each other. And by looking at that orbit, you can then calculate the mass of Pluto quite exactly. And it turned out to have only about 0.2% of the Earth's mass. Not 2%, 0.2%. It's actually a very small object. So it's seeming less and less planet-like over the years, less and less like the other planets. Not that at that point there was a strict definition of planet. But all these things sort of cast doubt on whether we ought to be thinking of this as something comparable to all these other bodies that we call planets in the solar system. Maybe it's telling us something different. And of course, that turns out to be the case. Over the years, there have been, we're here to talk about the spacecraft exploration of Pluto, which is just beginning. But over the years, astronomers have been studying Pluto and Pluto's system and finding out a few little things about it. If you compare this list of facts here with what we know about, say, Mars or Venus, you'd be entitled to say we know next to nothing about Pluto. Just these little bits of information that we can get, that there is this object called Charon that co-orbits with it out there. They were able to determine, from the albedo measurements, that Charon must have water ice. That's already kind of intriguing. So there's these two bodies out here. One has methane ice, the other has water ice. That's an interesting difference. Why is that? 1989 was when Voyager 2 flew by Neptune and made the first in situ observations not only of Neptune, but of Neptune's moons, one of which is Triton. And they noticed that Triton looks a lot like Pluto in terms of its size, and it's got this methane atmosphere around it with methane ice on the surface. It kind of looks like it might be sort of a model for Pluto, which sounds a little bit like the earlier theory that maybe it was an escaped moon of Neptune. But no, we don't think that anymore. But it's curious that that Triton, the moon of Neptune and Pluto, have some resemblances to them. What does that mean? In 1992, things really began to open up because astronomers were still studying the outer solar system the same way that Clyde Tombaugh had been studying it, by looking at images and then of a part of the sky, and then you come back sometime later, a week later or whatever, a month later, and you compare again and you see if anything has moved. And it took until 1992 before what were called Kuiper Belt objects, KBOs. I should have spelled that out there. Kuiper Belt objects, 1992. Other KBOs were discovered out there in the solar system. My guess is that Clyde Tombaugh, the guy who discovered Pluto, was really lucky, for any number of reasons that we won't go into right now, that he discovered Pluto out there in 1930. In the normal course of astronomy, I'm now doing counterfactual history here, but in the normal course of astronomy, it sounds like Pluto might not even have been discovered until 1992, when astronomers began really systematically looking at the plane of the solar system. Of course, they were doing that in part because Pluto is already out there, so that doesn't quite work. But other Kuiper Belt objects, that is to say objects out in the solar system, started to be discovered, and suddenly now all these weirdnesses about Pluto start to make sense because we're realizing we're talking about a different class of objects completely. And I should have put these points in slightly different orders, but I did chronological there. In the early 2000s, it turned out that from Hubble Space Telescope observations that Pluto has not just that one moon, Charon, but 4 others as well, much tinier than Charon. So by the early 2000s, 10 or so years ago, it was clear that there was a lot more going on out there than was originally thought. Sort of the original picture of a solitary, icy world, probably in a deep freeze where nothing ever changes out there, is not the case. It's complicated out there. The Pluto system itself is complicated, and the environment that it's in is complicated because of the existence of the Kuiper belt, which I'm going to talk more about in just a minute here. I wanted to mention one particular way in which astronomers learned about more about Pluto. And this was really just kind of lucky because Charon was discovered not too long before it started a series of eclipses of Pluto. And nobody would have been looking for these if they hadn't found Charon. Basically what happened was the orbital planes aligned. The orbital plane of Charon began to align with our line of sight out to Pluto. And as you can see them down here, Charon started eclipsing, moving across the face of Pluto. So when that happens, of course, it blocks some of the light of Pluto. And the light that you're measuring from Pluto, here there's no eclipse, so the light from Pluto stays constant. Here, Charon moves in an eclipse across Pluto, and so the amount of light that you're measuring dips down for the period of the eclipse and then rises once again. That allows you to derive all kinds of interesting things, including, among other things, the exact size of the planet, which, because nobody had ever been able to see the disk of the planet, nobody really knew the exact size. They've been doing a lot of inferring about the exact size. If you can get the exact size and you know the mass, then you can get the density. And when you have the density, you can start talking about the composition of the planet. And what came as a little bit of a surprise is that that Pluto, which had been expected to be an icy ball out there, Pluto turns out to be fairly rocky, not as icy as it had been thought. Whereas Charon, because you can measure its diameter and do its density too, turns out it's not rocky but icy. So here's another interesting contrast. These two objects, fairly close together, but they're very different from each other. And in fact, lately astronomers think that maybe it's a model, maybe it's another example of something that we think actually was the origin of Earth and its moon. There are a number of parallels that are kind of interesting. The Earth and its moon are thought to have originated when sort of a proto-Earth, if you will, and another now destroyed planet that was orbiting the sun, when those two objects collided. And the result of the collision, which is usually known by the phrase a massive impact, meaning two really big things collide with each other, the product of that massive impact was the moon, was the production of a big satellite relative to its primary. And it's entirely possible that we're talking about the same thing here with Pluto and Charon. That's currently the favored way of viewing this system. In fact, using models that astronomers put together to try and explain the formation of bodies out of gravitational collapses, there are those who say it's actually impossible for this system to have formed by gravitational collapse. It must have been a massive impact. The angular momentum of the system is said to be too high for that. That assumes that we know what we're talking about with these models, but when you take the models that we can talk about, the conclusion is that a massive impact is the likely way to look at this. So that is now making Pluto and Charon, that system, look like an interesting parallel for our own. So it might be going to tell us not only about way out in the outer solar system, it might begin to tell us about our own part of the solar system, rather surprisingly, where things are usually pretty different. But this may be an interesting clue.
Jim,
Yes.
I just want to make sure Charon is a moon in addition to the other four moons which rotate around.
Well, so we might have.
Like a dual
Yeah.
type of.
We might have to talk about what we mean by moon, and I'm going to get to that in just a minute. So, in addition, so now again, since 1992, there have been more and more of these things out there. And there's another piece of jargon that we sometimes see. These things are also called trans-Neptunian objects. So that means anything outside the orbit of Neptune, which unfortunately means everything in the universe outside the orbit of Neptune. So it may not be a very useful term, But you will see that, and there have been more and more of those things, and some of them are maybe not members of the Kuiper Belt, and so that might be why we'll still see that term around there. But there have been more and more of those things discovered since 1992, and in fact, as the slide says, over 1,000 of them now known out there. So this is just a story of the outer solar system becoming constantly more complicated than anybody thought it might be. Here on the slide, you can see some examples, and if you look down at the bottom there, you see the edge of the Earth, so an indicator of the size of the Earth, and then you can see the Pluto-Charon system just there in the lower left. And you can see a few other systems up there, and then in the upper right, our own moon, Earth's moon. So that's kind of interesting too. This means that if our moon, the one that orbits the Earth, were in orbit around the sun, we'd probably be calling it a planet. So there's nothing about the object itself that makes it a moon or a planet, or maybe there's not anything about it, but at least in this case, if Pluto's going to be a planet, then the moon, if it were in orbit around the sun, would be big enough to be a planet too, right? Then there are these other things out there as well, including this one named Eris, which, true to her name, has caused a fair bit of trouble in astronomy. And you can see that Eris has not been visited by a spacecraft. It's difficult to measure the sizes of these things, as we have seen with Pluto, and as far as I know, there haven't been any transits, any eclipses of Eris by its moon, Dysnomia. But Eris, by all estimates, is about the same size as Pluto or bigger. So if Pluto gets to be a planet, then Eris ought to be a planet too. And astronomers were sort of facing a similar situation to when they started discovering all those asteroids. So if Ceres is a planet, then why isn't Vesta also a planet? And then there's a bunch of other ones, and suddenly we're faced with lots of planets. And so we won't go into this in any detail right now, but that was actually the comparison between Eris and Pluto that led in 2006 to astronomers coming up with a definition for the word planet, which had not been carefully and technically defined before, that ruled out Pluto and Ceres too, by the way, and called them dwarf planets. So just recently in the press, there's been a whole lot of talk about this, of course, as the spacecraft approaches Pluto. And Alan Stern, the principal investigator of the New Horizons spacecraft, said, well, actually, that was the astronomers. It's actually planetary scientists you want to talk to about the planets, and we never said Pluto wasn't a planet. So he's all in favor of just sticking with a planet and letting the astronomers have their special terminology, which maybe doesn't make any sense anymore anyway. So we'll see where that goes. But be prepared, because we could see the word planet redefined. In fact, I kind of hope they go backwards and say, well, let's not define it. We'll come up with a technical term that nobody already uses. Anyway, Pluto there and Charon are just two of these objects out there. Here they are, here's Pluto, I should say, compared to now the sizes of the other planets, if you could put them all on your tablecloth there and compare the relative sizes of the planets. You see little Pluto down there, way tinier than the Earth. And remember that it's extremely small, maybe too small. It's in the wrong orbit. It's part of a swarm of all these other things out there. That's what led to it being called a dwarf planet. It's also been called an ice dwarf. And you can easily get to the point of saying, well, who really cares? But because it's a member of the Kuiper Belt and possibly the largest or one of the largest members of the Kuiper Belt, we actually do care. Because this turns out to be this Kuiper Belt, which is named after the astronomer Gerard Kuiper, who probably pronounced his name Kuiper, he was Dutch. But Americans always say Kuiper. The Kuiper Belt is the biggest part of the solar system. You have the inner planets. We talk about the inner planets out to Mars, and maybe you count the asteroid belt and maybe you don't. And then we have giant planets, Jupiter, Saturn, Uranus, and Neptune. We call them gas giant planets. They have a certain similarity to each other, and they cover a certain zone of the solar system. But this Kuiper Belt, the recognition of which has only come about since the mid-1990s, is the biggest part of the solar system by far. So Pluto actually turns out to be an indicator of a major zone of the solar system that stretches a huge distance from about 30 astronomical units, which is roughly the distance of Neptune, out to about 50 astronomical units, which is beyond the orbit well beyond the orbit of Pluto. And probably there's a lot of stuff out there. So we know about Pluto and its moons, and we know about these 1,000 other things. Estimates are that there may be as many as 100,000 of these Kuiper Belt objects bigger than 100 kilometers in diameter, and who knows how many smaller ones. It's a very populous region of the solar system, similar to the asteroid belt. It's probably telling us something about the formation of the solar system. And then the largest of these is Pluto, the one that's been known for 30 years. The reason it might be telling us something about the formation of the solar system is you can find belts of material like this around other stars. And again, going back to models about how stars and planets form, it seems like the Kuiper Belt is not nearly massive enough. It should be about 10 times more massive than it is, according to the scientists who make these kinds of estimates and compare them to the belts of material around other stars. And if it were so massive, it should have formed a planet. There would have been enough mass out there to form like another Neptune. But there is no Neptune out there, and there's only a remnant of what seems like might have been there in the early formation of the solar system. So then we're entitled to ask, well, what happened? And of course, we don't know the answer to it, but one scenario, and it's fairly well accepted these days, that it's actually possible. We often think about these planets orbiting the sun in kind of a timeless fashion, like trains going around on a track. But it turns out the tracks can change. Planets' orbits can change, and they can move inward or outward from the sun. And as we study more solar systems around other stars, that's given a great amount of energy to the idea that planets can form, say a planet like Jupiter, out far away from a star and then end up really close to the star. And as that happens, it could send other planets further out or even eject them from the solar system, from that solar system. And we may be looking at something like that here. It may be that Neptune's just the handiest suspect, but Neptune might have migrated, they say, might have changed its orbit out from the sun, and in the process have modified that distribution of matter out there, the proto-Kuiper Belt, and expelled a lot of those objects out of the solar system, or possibly absorbed a few of them, so that it's a remnant now of its former self. That would mean that these things, these objects out there in the Kuiper Belt, are examples of what astronomers call planetesimals, which are the chunks of things that form planets. Now, if you've been following another space mission, the Rosetta space mission that's currently exploring a comet, that comet is, the composition of that comet is probably a pile, it's probably a snowball of planetesimals, a bunch of these building blocks that coagulated around the sun and then build up into larger objects. At a certain point, gravity becomes important, and when their gravitational field is strong enough to draw in other material, maybe that's how you get a planet. But when they say small, they only stick together if they bump into each other and don't destroy each other. But you could have two that bump into each other and form a slightly bigger one. And it's looking like this comet may be, that we may be able to actually see the structure in this comet of these planetesimals that stuck together to form this cometary sort of body. And that may have happened way out there in the distant solar system, because comets are very icy and it couldn't have stayed close to the sun for very long without dissolving. So out there in the Kuiper Belt, we may be looking at planetesimals. We may be looking at these primitive objects that formed early in the solar system, and then by this event, this migration of Pluto or whatever, were scattered out into the outer reaches where they've been in the deep freeze for a very long time. So that's one of the reasons I've been trying to lay out the reasons why this New Horizons spacecraft is so scientifically interesting. This is why planetary scientists are watching this. What is it going to tell us about this unusual part of the solar system that's been so recently discovered? So it's taken a long time to actually get to exploring Pluto, not by telescopes, but by sending a spacecraft out there to take a good look at it. So the New Horizons spacecraft was launched in 2006. Did anybody here have an iPhone in 2006? The answer is no, because they haven't been out that long. Nobody had an iPhone then. Smartphones have come along since then. I just want to point out this was built with a technology of another age. This spacecraft was designed and launched and was on its way by 2006. And even with that primitive technology of the 1990s, it's still operating out there around Pluto. It got to Pluto in a reasonable amount of time. Pluto's way out, and it would have taken quite a long time if we had to depend on just what boost we could give a spacecraft with a rocket to get out there. But it was launched with the fastest launch speed that anybody had ever achieved with a spacecraft, about 36,000 miles per hour as it left Earth orbit, but that still wouldn't have been good enough. It was actually launched towards towards Jupiter. Jupiter was the first target, and the idea was to fly by Jupiter and do what's called a slingshot, a slingshot maneuver, in which you pick up a little bit of Jupiter's orbital energy, not very much in the case of the New Horizons spacecraft, and you get a boost from Jupiter. And the combination of those two things, the very fast launch from Earth, the fastest ever, and the slingshot effect from Jupiter, got it out there in 10 years, which is pretty remarkable given how far we're talking about. We're talking about it getting out there billions of miles away from the Earth. It will, of course, as I mentioned, be the first to Pluto and the first to explore the Kuiper Belt. By the way, you can sort of see in that photo, I don't know if you've noticed there, but you can see the technicians below it. If you've seen other pictures of spacecraft, this is not very big. This is not really all that much bigger than the grand piano that's sitting at the back of the room there. Keeping it small is one way of making it go fast. With the same amount of rocket power, you can send a small thing faster than a big thing. So keeping it compact, it had to last a long time, and so it's made very simple as well. And the simplicity of the spacecraft comes into some of its operations, which we'll talk about here just a little bit. As I mentioned down here, it cost about $720 million to build, to develop, to build, launch, and operate the spacecraft. That actually makes it a really good deal. About 24 cents per mile is what I figured. About 3 billion miles it's got to go. Actually went farther than that. That's just kind of the straight line distance from Earth to Pluto right now. And that included everything. My van, I did a quick calculation, costs about 12 cents a mile to operate, and that's just the fuel. I don't know if I put the cost of the van in and maintenance in there. So it's really quite a good deal. I think per mile it's got to be the cheapest one ever carried out. So just to give you a real quick animation, I picked this off of a NASA website. I think this is going to work. It looks like it's going to work. To show you the trajectory that the spacecraft took away from, let's see if we can expand this here. After launch, there's launch from Earth in the middle. There was the flyby of Jupiter. You can see the little bend where it picked up some energy from Jupiter there on the way out back in 2007. And then the flyby of Pluto out there. So it's a pretty direct route. It didn't take a lot of orbits and things like that to get around out there, but took a pretty good route. Pretty not straight line, but a pretty direct path. Now, can I get this back to go back, please? Exit full screen. Oh, it'll work in a minute. That went too far. We'll be back at it in just a moment. All right, and let's get by this real fast before it tries to run again. Okay, so 10 years, not quite, 9 years, and 3 billion miles is about the distance out to Pluto that the spacecraft had to go. There's a lot of fine print here, which I'm not going to go into at all, but you see the launch there, January 19th, 2006, flyby of Jupiter there, then the long cruise out to Pluto, and the flyby, which occurred this morning. Now, as I'm going to talk about, we're going to talk about what it did during the flyby, but as we stand here and speak right now, all that we can be sure of is that spacecraft, the New Horizons, flew by Pluto. It takes 4 hours to get a signal back from Pluto, and there are reasons why it didn't send a signal, or it might not have sent a signal, until about 4 o'clock this afternoon. It takes about 4 hours for the signal to get back. That's how long it takes light to get us, the radio signals to get to us from the spacecraft there. And the spacecraft, if it phones home and says, I'm okay, and I've got a lot of pictures for you, everybody will be really happy. That signal is supposed to come in around 8 p.m. tonight, so about the time that we'll conclude this talk. So we can be sure, just because Newton knew how to make these calculations, Newtonian physics assures us that this thing will have flown by Pluto. Everybody, the scientists all hedge just a little bit because we don't actually know that there isn't, say, a ring of ice particles around Pluto that nobody would have ever seen before, and it would only take one. The spacecraft flies by Pluto at about 31,000 miles an hour. So you can imagine what a pebble off of a dump truck does to your windshield. At 31,000 miles an hour, the spacecraft will be toast. So it's fine, but we'll know when it actually phones home. So among the scientific questions that the New Horizons is out there to explore is the primary goals are to look at the atmosphere of Pluto, which we know is out there. It has some nitrogen in it. It has some carbon monoxide in it. It has methane, and the methane appears to be both gaseous and frozen on the surface, which suggests something like weather, that maybe there are phase changes. But under what circumstances and just what's happening, we don't know. So study of the atmosphere and what's happening out there. Pluto has kind of a reddish color, which is attributed to, well, what can give you a red planet? Well, in the case of Mars, the oxidized iron on the surface of Mars is usually said to be the reddish color on Mars. That's not what we're talking about here with Pluto, almost surely. More likely, because we know we have methane up there, so we could have organic chemistry, is probably some organic molecules that have a reddish color to them. That's already pretty intriguing too, because what kind of chemistry can happen out there in the deep freeze? How does it get enough energy out there for interesting chemical things to happen? Maybe UV light from the sun or something along that line might be driving these things. We also know that Pluto is not perfectly uniform. It at the very least has dark and light splotches. I'll show you a fairly recent picture in a moment. This is still an artist's conception there. But why would it change out there? Why would you have a non-uniform surface? Well, again, maybe this weather, maybe this organic chemistry, certainly impacts are a possibility. But even more intriguing is that there might be processes out there that are analogous to the moons, for example, of Jupiter and Saturn, which have, for various reasons, crusts over, in those cases, oceans of water. And in a case like that, you can actually have what looks a little bit like the plate tectonics on the Earth. These things can move and change with respect to each other. We don't know if that's happening on Pluto or not, but it might be, and which would be really fascinating if it is out there. And the spacecraft should help us understand that better. Charon is going to be really interesting. That is studied as well. Remember, it has seems that no atmosphere, but we'll be able to refine that. What exactly is its surface composition? And it too has light and dark areas on it. We know that much. Does that mean anything interesting like surface activity? So these will be primary goals here for New Horizons to study and tell us about. Also, I've mentioned a couple of times that Charon's status as a moon, that may not be a good way to talk about it, as you raised earlier. In the case of two objects, when they orbit about each other, they actually orbit about their common center of gravity. And if they're of equal mass, then their common center of gravity will be halfway in between them. Well, we don't have any planets that do that. In the case of the Earth and the Moon, that common center of gravity is in the Earth. So it looks like the Earth is the center of the Moon's orbit, although the Earth is moving just a little bit as the Moon orbits it. In the case of Jupiter and the Sun, they orbit about their common center of gravity, but the common center of gravity is in the Sun. So again, you can say that Jupiter orbits around the sun, which it does. But you can't say that, it turns out, about Pluto and Charon because they actually orbit around their common center of gravity, which is not inside the planet Pluto. So Pluto is out there going around a point in space, just as Charon is out there going around that point in space. And so describing this as a binary planet, except that Pluto isn't a planet, a binary dwarf planet, I don't know, a dwarf planet with a binary moon. Anyway, it's whatever it is, these two bodies are more comparable in mass than any other pair of bodies in the solar system. So understanding this a little bit better as a binary system is a really important part of the scientific goals as well. And finally, the contrast between these two things. The contrast between the two surfaces, the potential interactions between the two surfaces, and then all the stuff we can't see, like maybe there are dust belts or ice belts or something else out there. Stuff we can't guess. We're always looking for the good stuff that we don't expect, of course, out there. The instrumentation on the space probe, compared to some, is relatively straightforward, relatively simple, and the spacecraft itself is mechanically very simple. You can see the part of it down here that is sort of the grand piano size thing, and of course it has an antenna. You can see the antenna there, which is about the same size. And then the diagram shows you the various instruments located around the instrument, the space probe. And just to take them in order there, one of them does ultraviolet spectroscopy. So you study the spectroscopy, the spectrum of the light of these objects in the ultraviolet, which is a lot about composition of the atmosphere and the surface. There are two imagers, which just means cameras, things to take pictures of the surface. And those, you can see the names that the scientists have given these various instruments. I'm not sure what was going on with Ralph and Alice. It's probably out there on the internet somewhere, but I didn't read up on it. And then the other instruments are the traditional NASA acronyms. So there's another imager, and then two particle detectors, a dust detector, and then finally the antenna, which is also used for communications back to Earth, will be used for studies. They're going to actually beam radio waves. They did already beam radio waves out in that direction from the Earth, so the Earth would look bright in radio wavelengths, and that antenna looks back at the Earth, and then as the Earth passes, as seen by the spacecraft, as the Earth passes behind the planet, those radio waves from the Earth, that signal, can be analyzed for information about the planet. So the radio occultation experiment is actually done with the communications setup of the spacecraft there. So we've been seeing various images. And I don't have the very latest images here. There was one image sent back just before the flyby. This one is kind of interesting. You can sort of see that's Charon orbiting around there. And can you detect the error in this? It looks like Pluto isn't moving, but Pluto's actually going around its barycenter there. But they chose to keep Pluto centered on this animation here. You can see Charon orbiting around, but you can see Pluto getting bigger. Can you see that? So we're actually approaching Pluto there during this series of images, which looks like must have taken roughly a week, about one Charon orbital period there. So this is not the best image so far. This was the best image at the time I made up these slides, which was just last week. And this was approximately the same hemisphere that was facing the New Horizons when it flew by. One of the consequences of a flyby, especially a fast flyby, is that we're only going to see, well, I should say we're primarily going to see one face, one hemisphere of Pluto. So it's got another side, and we're not really going to get highly detailed images of that. This is roughly the same face that we'll see in the really highly detailed images, and this has been talked about a great deal. I'm not going to go into it, but if you look, you can easily see the big contrast, this big white area here and these very dark areas. And again, the question is, what's going on here? It doesn't really look like impact. It looks like some interesting surface science, maybe geology going on there on the surface. But this is the hemisphere they're going to see at much higher resolution, estimated to be in the area of a few hundred meters per pixel. So the smallest things we'll be able to see will be like, sort of parking lot size objects. So if you image the center here where Space Place is at that resolution, you'd be able to tell the building from the parking lot from the street, that sort of thing. It's not going to be Google Earth type resolution where we can pick out the license plates on the cars up there or anything like that. But we will have pretty good resolution at a geographical sort of scale. So this is the profile of the flyby that was made by the New Horizons spacecraft earlier, and it passed right through the system of orbits there of Pluto and its moons. And here's the passed behind the sun passed behind the planet as seen by the spacecraft up here, and here is where the Earth occultation, where the radio experiments would have been done out there. The spacecraft was quite busy during this time. As it's going by in a fairly short period of time, it's got to point at Pluto and it's got to point at Charon, and it has to keep on pointing back and forth between its primary targets as it passes through here. The instruments, in order to keep the spacecraft simple, primarily, the instruments can't point themselves independently. So you have to turn the spacecraft in order to aim your camera over there, or turn the spacecraft again in order to aim it up there. That means that while you're doing that, you can't keep your communications antenna sending back data to Earth. And so that was put off completely until after the flyby. So basically the spacecraft has been maneuvering itself around to turn the different instruments at the different targets. Remember, there's not just one, there are multiple instruments there on the various targets to carry out the whole science program during the flyby, which took some hours there, as you can see there, at least a few hours, 11 there to 15. A few hours during the flyby gathering data, and it was only after all the science had been done that then it's programmed to turn around and face the Earth and say, okay, I'm done and I'm still here. And we won't hear that if anything dramatic happened to it on the way through here, like running into some ice particles or something. I don't mean to overemphasize that. That's pretty unlikely, and they've actually been watching for that kind of thing, ready to try and modify the path should they see any sorts of threats. But if we're going to get that message, we should get it tonight, and if it isn't already in, the predicted time was about 8:02 p.m. our time, which is not quite 10 minutes away from right now, and then we should expect some NASA briefings at about 8:30. So if you want to go home and turn in the television for that. The flyby of Pluto, so we're waiting to hear about that, but the flyby of Pluto, if all has gone well, will not be the end of this mission. You've got this thing already heading out there at high speed. It's only going to spend a short amount of time on that flyby around Pluto. And so if all goes well, then we're going to get the images from it over the next days and actually weeks, and the data rate is so slow that some estimates say it might take a year and a half to get all the data down to us. It depends on a certain number of things, which include just how much time NASA's Deep Space Network can spend talking to New Horizons and not doing other stuff. So if they had more time to talk to Pluto, the data to New Horizons, the data will come back faster. And certainly the analysis is going to go along for many years. And while that's happening, New Horizons will be heading, in all likelihood, for yet another target, because along its trajectory. So we saw the animation, the trajectory out to Pluto, but it's a flyby. It is not going into orbit around Pluto. It's just going to go by and keep on going out here. And it turns out that there are some other objects out in the Kuiper Belt that it may be able to fly by. So these are the candidate objects. And after the flyby, the mission team will assess where they are and probably decide to go on with the mission and explore another one of these things. In that case, they'll choose one of these Kuiper Belt objects and then adjust the, there's a little bit of rocket power on this spacecraft to make course adjustments. They'll choose their target, adjust the trajectory, and then head out there. Depending on what they choose, we're talking 2018, 2019, something like that. So a cruise of a few more years, 3-4 years, before it makes it by another Kuiper Belt object. And that will be really interesting. It's really, we keep talking about New Horizons as if it's a Pluto mission, and it is, but the thing that really unifies all of this is the Kuiper Belt. It's a Kuiper Belt mission out there to the outer solar system. So that's the end. Thank you very much.